Hi guys, let us look at the concept of elasticity and Hooke's law. Elasticity is the ability of a material to return to its original shape and size after a distorting force is applied. And any material that possesses that kind of characteristic is known as an elastic material. Examples include spring and rubber, just to mention two of them. Now we are going to look at Hooke's law, which is which demonstrates how to properly understand what elasticity is and how materials that are elastic actually behave. According to Hooke's law, if we apply a load to an elastic material such as this spring, the first one here, you can see that the spring is suspended and it is pulled down by its own weight. In this second image, there is a mass that is attached to the bottom of the spring, and that mass created an extension x, which means it pulled the spring through a distance x. The mass was doubled and it pulled the spring with an extension that is twice the former one, which is 2x. What it means is that as you are applying a force to a spring or an elastic material to extend that material, the material extends proportionally to the force. Same thing happened for compression. If you put a mass on top of the spring, it compresses it. If you increase the mass, the compression increases. And if you further increase the mass, you have a further compression. You will agree with me that it is logical to say that when these masses are taken off the spring will return back to its original shape, which is either this or before this compression load was applied. So, because the spring can return to its original shape after removing that distorting force, we say that the spring is an elastic material and it possesses the characteristics of elasticity. Now, what is the relationship between force and the extension or compression created by the spring? Hooke's law now states that the force acting on an elastic material or applied to an elastic material is directly proportional to the extension produced or compression produced. What it means is that if you increase the force, such as increasing the weight, the extension increases proportionately. In mathematics, if you take out the proportionality sign, you introduce a constant, and that becomes F equals to KE. The proportionality sign has changed to an equal to sign, and we introduce a constant K, known as the KE. Now, sorry, K, known as the constant of the elastic constant of the material. So if we make K subject of formula, K is equals to F all over E. This K is a constant for every material, which is the elastic constant. It is what describes the kind of material. If it is more elastic than other type of material, so it is a constant value, and it has a unit called the Newton per meter. Newton per meter because the unit of force is Newton and the unit of extension, which is like length, is meter. So the unit of the elastic constant of an elastic material is Newton per meter. So this describes the relationship between force applied to an elastic material and the nature of extension or compression that is achieved. We can further demonstrate this using a graph known as the graph of Hooke's law. And this is the graph. It is a graph of force plotted against extension. It means as you are applying force to an object, to an elastic material, how is the extension produced? Between the origin and point P, or point P in the graph, is called the proportionality limit. It is the limit where Hooke's law is obeyed, where this proportionality equation is obeyed. It means that between this origin and point P, this equation is valid. Beyond point P, the equation is no longer valid because you have gone beyond the proportionality limit. When you apply a force to an object, as the force is increasing, the extension is increasing. Hence, we have this slope on the graph here. Between P and E, or rather point E, is known as the elastic point. It is the point where the elastic property of the material is maintained. It means that before this point, the material can return back to its original size. However, beyond this point, the material is no longer elastic and it will be difficult for the material to return to its original size and shape. Point Y is known as the yielding point. It is the point where the material has yielded its elasticity. What it means is that beyond points at point Y or between point E and Y, the material no longer returns to its original shape, even when the force you have applied to it has been removed. That is when you say your elastic material has slacked. It means it doesn't have ability to return back to its shape and size again because it has yielded its elastic property. From point Y to point B, the material undergoes a strong tensile stress. And at point B, we call this the breaking point, which is the point at which the material breaks. It can now break, cut into one or two or three pieces. So between point Y and point B, the material could still have some tensile stress on it, but up to point B, it breaks. So P is the proportionality limit, E is the elasticity limit or the elastic limit, Y is the yielding point, while B is the breaking point. These graphs demonstrate how elastic material operates when external force is applied to them. I hope you enjoyed this video and thank you very much for watching.